is the solution to DP50. Okay, in this problem we were looking at a very simple circuit. This was for an introduction to circuits, and the problem was we had a battery that has a potential of 18 volts connected across a 100 ohm resistor, and the first part A, was to draw the circuit. And so when we draw out the circuit, it looks something like this. We have the battery and we have the resistor, and this is an 18 volt battery, and this is a 100 ohm resistor. And that's the first part. Part B asks to find the current through the circuit, and using Ohm's law, we know that current is equal to the voltage divided by the resistance, and we can sub in 18 volts divided by 100 ohms, and when we solve that, that works out to 0.18 amps. Part C asks us to find the power consumed by the resistor, and so we use the power equation. P is equal to IV, and subbing in for that, we know from the above problem that the current is 0.18 amps, so 0.18 amps, and the voltage in this circuit is 18 volts. So we can go ahead and solve that out, and that comes out to about 3.2 watts. The final part to this problem, potentially the trickiest, talked about how to find the number of electrons flowing through the resistor each second. And so from part B, we know that the current in the circuit is 0.18 amps. That's also another way to express that is 0.18 coulombs per second. And so if we look at this at a per second basis, we don't need to care much about that denominator. And we can say that the charge flowing is equal to 0.18 coulombs, and that's 0.18 coulombs in 1 second's worth of time. We can straighten that out a little bit. Coulombs in 1 second's worth of time, and we also know that 1 electron is equal to 1.6 times 10 to the minus 19th coulombs. Dimensionally, this works out, right? C and C cancel out, and so the charge that flows by in 1 second works out to be 1.1 times 10 to the 18th electrons. Okay, and there we have it. Simple circuit. And the trick to this, of course, any of these is defining the variables and making sure that it's consistent.